Good morning, everyone, and welcome to today's webinar, Data Lakes in Your Enterprise Data Warehouse. I am Megan Souza, Marketing Manager here with Done Solutions Group. Before we get started, I would like to go over a few items. This session will be recorded, and we will send out a link to the recording to everyone who registered within 24 to 48 hours after the presentation. We also have recordings of all previous webinars on our website in the event that you missed any in the past at donesolutions.com. Also, if you have any questions during today's presentation, we encourage you to submit them, and we'll address as many as we have time for at the end of the presentation. If the question is somewhat complex and we need more time to answer, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Done Solutions. From there, I will turn it over to today's presenter, Manish, our Senior Analytics Manager here at Done Solutions. Manish will begin by discussing a data lake overview. He will then discuss the differences between a data lake versus a data warehouse. He will discuss data lake use cases and data lakes in the cloud, as well as data lake case studies. So let's begin. Done Solutions is a digital commerce and business transformation consultancy focused on delivering velocity to our clients. Velocity is achieved by the combination of both speed and direction. Done Solutions helps our clients achieve speed by automating business processes and direction using advanced analytics. Our teams align with organizations to optimize their unique processes and help them discover the most profitable routes to business success. We have a long history of delivering innovative business technology solutions to companies. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature analytics and BI platforms, as well as data warehouses and data integration. We are authorized SAP and Liferay training providers, as well as Microsoft. We offer classroom, virtual, private, and custom options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are included here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business are commercial clients and 20% are nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our application development practice develops solutions that are custom and help differentiate our customers from their competitors. We provide solutions on portals, e-commerce, and content-managed websites, custom transactional applications, as well as mobile applications for integration with back-end systems. We've been doing application development since our inception in 1988, and it's one of our core practice areas. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. We've built solutions for customers which help them better manage their sales operations and inventory predictions, even helping determine where to build the next hospital. We make it easy for them to get that information using tools that don't require you to be a programmer so that analysts and line of business managers can easily access the data that they need to run their business better. Thank you for allowing me to introduce you to Done Solutions Group. I will now hand over the presentation to Manish. Welcome, Manish.
Thank you, Megan. Good morning, everybody, and maybe even good afternoon, depending on where you are. And thank you very much for taking the time to join us this morning. Just a little bit about who is Manish. My name is Manish Motiramani. I am a senior manager at Done Solutions Group. I have been with the company for almost 10 years now, and I am also a very hands-on architect when it comes to designing solutions and creating content for our clients here. With that, let's get started. What is a data lake? The term data lake has been thrown around a lot. Very often it it gets mixed up with big data. Is there a difference between a data lake and a data warehouse? So what is a data lake? Data lake is basically a storage repository that can hold vast amount of data in raw format. And when we say raw format, these could be structured data coming from your OLTP systems, your ERPs, your CRMs. It could be semi-structured data that you get from sensors, that you get from your external vendors like clickstream data, and quite a few other things. And it could also include unstructured data. Some good examples of unstructured data would be social feeds, documents and texts, or email, images, videos, audios. So a data lake can store, ingest any of those kinds of data sets. Well, that is what a data lake is, but what is the purpose of a data lake? The main purpose of a data lake is to democratize your data, allow multiple people to access it, make it easy for people to access your data, spend time on the analysis versus spending time on where is the data, how do I find it, how do I get it. Let's talk about the data lake ecosystem. And why is it called a data lake? Because it is very synonymous to a real lake, just that this is a man-made reservoir of data. And it can be consumed for a variety of different purposes. Let's talk about what are the parts that make up a data lake. So there would be inflow of data into your data lake. And as we said, the data can be of any kind. It could be structured data coming from your transactional systems in rows and columns. It could be semi-structured data, data feeds, different file types. These could be CSV or TSV files, or they could be the newer JSON or the Avro format of files. And it can also do unstructured data, social feeds, text, images, quite a few other things. So that's how the data, those are the different types of data sets that can come into a data lake. Obviously, there has to be storage in a lake. So when all of these data sets come in, they are stored in a relatively economical storage structure, which is distributed over multiple systems. So multiple distributed storage with distributed compute as well is what makes up the data lake. But talking about compute, what happens after the data is stored in a lake? It has to be consumed, and it can be consumed in multiple different formats. You could have your data scientists and your data analysts looking at the data. That data lake can be feeding your data warehouse, or it can also be feeding your predictive applications, machine learning models, and quite a few different things. So that sounds very much like a data warehouse, right? How is a data lake even different from a data warehouse? Is this just a new term? Can I throw my data warehouse away and start using my data lake instead? The answer is no. The data lake is not your data warehouse. They both have different purposes. They're optimized for different things, and you want to use the best tool for what it can do. Not just have a one-size-fits-all. And we'll talk about different things. Let's see what the differences are between a data lake and a data warehouse before we jump to any conclusions. So talking about what are the major differences between a data lake and a data warehouse. Data warehouses have existed for a few decades now, 3, maybe even 4 decades now. They have been commoditized in the last 10 or 15 years. The usage pattern of a data warehouse has gone up drastically. So they are a lot more accessible to users or to businesses now than they were about 15 years back. So what are the characteristics of a data warehouse? I am assuming everybody on this webinar would know or would have gone through a data warehouse lifecycle or is using an existing corporate data warehouse in some form or another. So you'd be easily able to relate to these points. A data warehouse is very focused on business processes. You could have a data mart for finance, you could have a data mart for sales, you could have a data mart for marketing. So you start off with the business process that you want to create a data mart on, and then that's how you begin. That's your first question. What do I want the data mart to be used for? What will be my end goal? How will the data be used? You don't have to get all the questions up front, but at a very high level, you have to know what are my facts, what are my dimensions. Once you start building it, the data that goes into the data warehouse is highly processed. You would use an ETL system. The T in the ETL stands for transformation. You'll be doing a lot of cleanup, processing the data, aligning it across different systems. A very simple example would be you would have multiple systems sending you customer data. One system could say the gender is M or F, and the other system could say male or female. You will process the data so it aligns all together. It should globally say male or female, or it should globally say M and F, not a combination of the two. So data warehouse does take care of a lot of these things, and all the data in the data warehouse is structured into tables. No exceptions here. So as you can understand, with the data warehouse, there's a lot of effort to get the requirements right, to do a very good design, and do a build. And most data warehouse projects can take 2 to 4 months at the very least, from the time you start talking to your business users and their requirements to the time it is exposed in production. These systems are highly optimized for data retrieval. Once the data is in there, they would serve the 80-20 rule. About 80% of the questions that you ask will come from 20% of your data. And these systems are highly optimized to retrieve that 20% of the information, and in a very fast way. And a data warehouse is highly governed. You would have a lot of processes in place to make sure the data is clean. You would have a lot of security in place to make sure that the right people get access to the right kind of data. Let's talk about data lakes now. How does data lake differ or is similar to a data warehouse? So where a data warehouse, as we said, is the 80-20 rule, it stores about 20% of your data, and it could be more than 20%, but of late data has been growing so much that the data warehouse may not be the right place to put all this data, whereas a data lake can store everything. Over the last few years, we have seen data grow tremendously. Most organizations have their data volume double or maybe even triple every 2 years. And organizations have come to realize that all data has value. And sometimes when you're building a data warehouse, you would not bring in some columns thinking they would never be used. An example would be defining a price of an item for a sale on an order line. There could be 5 or 6 different components that go into it. What is my usual price? Am I taking any markdowns? Are there any discounts? Are there any coupons that I'm applying to this? And sometimes you would think that, oh, you know what? I don't care about, for example, markdowns. I don't know if the item was marked down or not. I just want the final price of the item. And that's what you would store in the data warehouse. Whereas in a data lake, you would have raw, unprocessed data from your systems. So you would store all of the columns that we described to calculate the price of an item on an order line, for example. Whereas the data warehouse is very tabular and structured, the data lake can accommodate all kinds of data. It can obviously accommodate structured data. It can do a whole lot with semi-structured data, which could be JSON, TSV files that you receive from your vendors. It could also be unstructured data. In fact, there are some very great examples of how unstructured data, things like images, are being used. There's some good processing engines now for image recognition. Facebook is using some. Bing uses some very good image recognition options. And one example was the Boston bombing. After they recognized who the culprit was, the Boston police reached out to everybody saying, all the pictures that you've taken, please post them on social media and give us access to it through Facebook or some social media. They were then able to go back, recognize an image, and find out where that person was in all of the images and create a timeline on a map saying this person was at point A, then he went to point B, and he went to point C, and this is how he executed it. So there's some very good insight that you can get from unstructured data. The world is definitely not mature enough yet to process all the unstructured data we have, but it is only going to get better from here on now in terms of processing images, processing audio, processing videos that we have. And if we are thinking at this point, you know what, I don't need to save all the audio. I'm getting audio on my CRM systems, or I'm getting audio on my customer support systems when people are complaining about a product that I have. Why don't I just take notes? There's a high probability that you will miss out on things. And sometime down the line, 2 or 3 years down the line in the future, you would say to yourself, I wish I had saved those audio files. So a data lake can accommodate. It is kind of future-proofing you from the technology enhancements that would come in the next few years. And obviously, a data lake allows democratization of your data. You want to get data into the hands of people who want it. There are some inherent, I wouldn't say problems, but there are some, a data lake is very optimized for storing data. The focus is to get the data in a central repository ASAP with minimal effort. The payoff to that is when you're retrieving the data. That's where a data warehouse comes in. The data warehouse is very optimized for data retrieval, whereas a data lake may not be. So you have to be cautious about the fact that you're storing all the data, and it will be used in some form or the other, but it's not for your everyday use with operational analytics. With the data lake, people generally think it is data that we get from anywhere and everywhere, and we throw it into the lake. And you have to be very cautious about data stewardship, what data goes in. Even though a data lake is flexible, it is not a swamp. And it is the job of the data stewards to make sure it stays that way. The data is structured and is flexible, but is vetted data. It may or may not be processed data, but it doesn't have to be a swamp. So it's not all of the data that we get which has not been vetted to, let's put that in the lake. No, that's not the right thing to do. Let's talk about the difference in the data structure between a data warehouse and a data lake. The structure in a data warehouse is very structured. And if you see, I cannot emphasize the word very enough. It is very, very, very structured. You spend a lot of effort up front in defining a schema. Star schema, as some of you may have heard about it. You have a central fact table, you have confirmed dimensions hanging off of that fact table, and everything has to be perfect in a data warehouse. Comparing that to a data lake, as we say, can have structured, semi-structured, and unstructured data, and it uses the concept of schema on read. You do not define a schema when you're putting your data into the lake. Your schema is imposed, and even transformations are made at query time, not at the time when the data is ingested into the data lake. As we say, the data lake, even though can have a lot of unstructured data, it doesn't have to be unorganized. Your data lake should still be organized. So an example here is I am getting vendor data from multiple sources. I get clickstream data, I get email campaigns that I've been running, I get weather data, and I want to put it all together. It's not just one area where you throw everything. You should structure your data well enough in folders for somebody new coming in to look at the structure and be able to understand what data is where, or not be confused as to, if I'm going to the clickstream folder, will it have my email campaigns? No, it will not have your weather data or your email campaigns. Let's talk about the approach that we use for building a data warehouse versus building a data lake. The approach that is used for a data warehouse is a very top-down approach. So you start at the very top, you know what business problem you want to solve, you have a theory, you create a hypothesis, then you make observations, and then you confirm if your hypotheses are correct or not. And if they're not, you go back up to the top and make some more hypotheses, make some more observations, and have some more confirmations. And that works very well for operation analytics, for what we call descriptive analytics and diagnostic analytics. Those are the first two things. As an organization matures in their data journey, they would start doing more predictive analytics and prescriptive analytics. And this is where you have to use a bottom-up approach. You make observations first. You start looking at your data first. And then you find patterns. Then you create a hypothesis. And then you have a theory. So a data lake is very much bottom-up, where you say, here's my data. Let me figure out how to store my data. And then let me worry about how do I use it. Let's just put all the data in a central repository. And then we'll figure out how is it going to be used. So that's how the difference in the development life cycle is. For those of you who have been through a development life cycle of a data warehouse, the very first step is gathering requirements, is defining the what do you want from your data mart, and defining the who would be accessing the data mart. Then you do your design at a very high level, saying these are my facts, these are my dimensions. Then you go out and identify your data sources. What are the different forms of data that I would get? Where would I get it from? Then you would write your ETL. You would define transformations on standardizing and cleansing the data. Then you load it into the warehouse. Once the data is loaded into your data warehouse, that's when you start consuming it, and then you refine it. After every so many cycles or so many months, you would do an enhancement to your data mart to get it closer to perfection. The development life cycle of a data mart or of a data lake is pretty different from a data warehouse. With a data lake, the first thing you do is identify the source of your data. Just tell me what kind of data sets I need. These may be internal, these may be external, these may be social feeds, vendor data, clickstream data, email campaigns, all of the nice things that you can think of. One at a time, you source them and you load them. You do not worry about doing the transformations just yet. Once the data is available to you readily, then you do your requirements on what do you need from the data. You design your schema on read, you impose your schema at that time, and you make transformations and you consume the data. Obviously, the refine cycle is a part. The only thing consistent in life is change, right? So you'd always want to refine it, make your processes better, be it a data warehouse or be it a data lake. How is the data loaded in a data warehouse? So you have data marts, you have your data sources, and you have your target star schema in data marts, which would roll up to a data warehouse. And you use a process called ETL, which stands for extract, transform, and load. So right up front, before you start any coding, you have to know where would my data be sourced from, what are the kind of transformations, cleansing, standardization, denormalization, and all of the other nice things that I have to do to my data. Once you do those transformations, you would load them into your data warehouse. there's a newer phrase related to this. So data is transformed when it enters the data warehouse. The newer phrase to this is called ELT. So a data lake makes use of the ELT process. I have seen in some examples where newer modern data warehouses also make use of the ELT process, but an ELT process is very much a standard in a data lake. So what do? We have our data source, we have our target data lake. We do not do extract, transform, and load. We skip the transform at this point. We do the extract and the load into the data warehouse in the raw format. The transformations are done when the data is retrieved from the data lake. That's a very important piece. As these systems get more and more powerful, the ability to do transformations on the fly is getting easier. The data warehouse theory was built 30 years back when databases were not as powerful, and we wanted to do a lot of pre-calculations before the data was available for reporting, which is very good, which gives you a lot of performance. But the downside to that is you cannot change things as easily. You cannot be as agile as you would like to be. Say there is a business process change and you want to change the way you are now calculating net revenue. It would be a project for a few weeks to go back to the drawing board, find out what processes are writing net revenue into your data warehouse, redoing those processes and reloading the data, reloading all of historic data. Whereas in a data lake, it is a little easier, not just a little easier, I'll say a lot more easier to change your transforms because you're doing a schema on read. So how is a data lake different? What makes a data lake stand out? This is a recap of a few things that we discussed. A data lake is an economical file storage. It allows for storing more data. One example of this is one of our clients is getting clickstream data on usage patterns of their website. The data is humongous. It's a few gigabytes a day. And a few gigabytes a day doesn't sound that big, but when you add it up to the week, to the month, to the year, at the end of the year, you have a few 100 terabytes of data. Storing all that data in a data warehouse is not practical. Another example is if you're getting any machine data, for example, any sensor data. One example that I can think of is a utilities company here in the Twin Cities where I'm located. They have a lot of meters across the cities to capture data, and each of these meters send data every 1 second, and the data is rolled up every 15 minutes and is available for reporting for a 15-minute period. Just that the raw data is coming in at such high velocity that they cannot store a lot of it. So they only keep the last N months or maybe even a year or a couple years of data, but beyond that they have to archive it, put it on a tape, and put it in a basement in a vault where it may be available. The 15-minute data or maybe higher resolutions or higher grains of the data are available to users for reporting. But if for some reason there was one spike in a 15-minute period, the average would be a little bit higher, but we wouldn't know looking at just the 15-minute grain, saying how many spikes did I have? How big was the spike? The jump in the data at that point. And for that you need the raw data, and it is just not practical to keep that in a database. It's pretty cost prohibitive. So if you put it in an economical file storage, you can retain your data longer. And if you're using the right methodologies and the right techniques, maybe you can store the data forever. Also, a data lake supports more types of data. It can do traditional structured data, it can do semi-structured data, We talked about sensor data. We talked about external data coming in from vendors. Some of this may be high velocity data. Some of this may not be. You may get batch every so often, but those would be huge files. And then we talked about unstructured data. I don't know if you've heard, but this has been a ghost story that's been going around for a while, that one of the retailers in the US is taking satellite images of its competitor's parking lot. And just by counting the number of cars they see in the parking lot of their competitor, they are able to predict what the competitor revenue would be. They know what is the foot traffic going into their brick and mortar stores. And again, I have no proof. I've heard this story multiple times, and that would be something that a data lake would be able to support. It can answer a wide variety of questions. Again, as we said, the 80-20 rule with a data warehouse, you are restricted. Most of the times you get answers to the questions you want, but there would be every so often where you have a question and the business users would go, I need that data set, and the data architects would know that that wasn't a part of the requirements, it is not a part of the data warehouse. It can be brought in, sure, but that means going back to the drawing board, doing a lot of analysis and reprocessing of the data to get it to the right place. Whereas a data lake can have this data available a little more readily. And again, you take a hit in a data lake when you're retrieving the data compared to when you're doing it in a data warehouse. But it is worth it. You get most of your reporting, operational analytics from a data warehouse, and the data lake is for your data scientists or your specific people who need different data sets all of the time. Also, a data lake is more adaptable to changes. One example that I can think of is one of our clients switched their email campaign vendor, and they were getting email campaign data from the previous vendor. They were putting it into a data warehouse in a very specific format. When they switched vendors, the data format that they were now receiving was completely different. In a data lake, you would take the raw files from your vendors and put them in. There would still be some effort in transforming it and consolidating the data together, but at least you're not missing out. Whereas in a data warehouse, you have to go back to the drawing board. Also, some other examples are source systems are continuously enhanced. Your ERP systems, you would start adding more columns as your organizations mature. And getting those columns into the data warehouse is, you cannot do that on the fly. You have to do it in phases. You have to know when you're executing the next phase and what is your scope of the phase. Whereas in a data lake, adding new columns is relatively easier. You can add that to your files right in the middle or towards the end of it, and still be able to combine older files which did not have that column and newer files which have the additional data, and maybe do a union all where the historic data will show up as null and the new data is available for reporting. And just because you can get more data faster, a data lake can provide new insight to you faster. When I say faster here, I'm using the term faster not in terms of performance, but in terms of the life cycle of getting the data into the hands of the user. And this is where it is very good fit for data science, where you're looking at machine learning or predictive algorithms, which may use a lot of columns that are not generally used for reporting otherwise. So now that we know a little bit more about a data lake, now what do we think? Does a data lake replace a data warehouse? The answer is no. They coexist. So this is where a modern data platform comes in. You would have multiple data sources, as you can see on the bottom. I would have structured data coming in from my OLTP systems, my CRM systems. I could have documents and emails coming in from various sources. I could have weblogs, social data, machine-generated data, sensor data, all of these things coming in, rather than ignoring the data, or rather than taking the data, staging it, uh, aggregating it and putting it into just your data warehouse, you would put the raw data in your data lake and you would put the processed data in your data warehouse. Your data warehouse could be a combination of on disk and in memory relational database systems, and your data lake would be all of the raw data for processing, so you can get to it sooner than going back to your source system, which may or may not have retained your data. For example, web logs or machine generated data can only be retained by these meters for so long. And if it's past a certain point of time, you cannot even get to that data. So that's where a data lake is very helpful. A data warehouse still has its place. You would still want to perform your operational analytics in your data warehouse. Your dashboards, your generalized self-service reporting and data visualization, a lot of it will still come from the data warehouse. Whereas a data lake would be for specific cases, low cost option, use it when you need it, kind of a deal. As good as a data lake is, you cannot just give it to your CEO and say, sure, go fish, right? The standard operational reports that are needed by an organization would still come from an enterprise data warehouse. And people like your data scientist, your data analyst would be the people who understand the data and know how to go get it. They have the skills of the business as well as technology to go get the data from the data lake. And all of this put together will be feeding, as you can see on the top, your application layer, your statistical analysis, your reporting and dashboards, your mobile applications, your enterprise applications. So the modern data platform is where an enterprise data warehouse and a data lake live together. It is not one or the other. Some use cases on when would you use a data lake. Data lakes are pretty good at storing massive amounts of data. Again, as I said, the example of clickstream data, very difficult to store all the raw data in a data warehouse. You may want to have some raw data, but eventually you'd want to roll it up. Inventory is another great example. Imagine a retailer as big as a Target or a Walmart, which could have hundreds of thousands of items, if not millions, and taking an inventory snapshot every day, saying what was my inventory count for a little Lego system, a little Lego game over a period of 1 year would be pretty close to impossible to do in a data warehouse, just because the cost would be so prohibitive. Whereas, so what these systems do is they keep a snapshot of the inventory at point in times, maybe at the end of every month or maybe at the end of every quarter. But the data lake is where you can have that raw data stored for an everyday purpose. And when your data scientists have that question as to, hey, what products did I have in inventory by the day consistently being high or consistently being low and unavailable, they can get to that. But that's not a question that your CEO may want to answer right on a dashboard on a daily basis. So these one-off questions, which would be different all the time, a data lake is a very good use case for that. Also, a data lake is very good at mixing different data types together. Your on-prem data combined with, say, your vendor data or National Weather Services data, for example. I did not sell too many winter coats in the month of Feb. Well, I now know that the month of Feb was way over average when it came to just the temperature. But would I remember that 3 years down the line when I'm looking at it holistically, or how did I sell winter coats in the last 5 years? Would I remember what happened? And that's where you can combine your sales data, for example, with weather data, And your sales data could be structured data, whereas your weather data could be semi-structured data in the form of a JSON or an XML file. Getting them together into a data lake and using them together is a very good use case. In fact, one of the use cases case studies that I'm going to talk about would make use of this example. A data lake is also very useful in ingesting high velocity data, IoT streaming kind of data. And again, I will not talk about that much just yet. I have a case study that I can share with you on how do we do that. How is a data lake useful when you want to apply, when you want to get high velocity data. You can also use a data lake to put structure around your semi-structured or unstructured data to add some method to the madness. And again, that is one of the case studies that I'm gonna show you. So I'll not talk about that much just yet. And then we also talked about a data lake could be a great source for machine learning and predictive analytics. There would be a lot of things that you would want. For example, when you're predicting customer churn or customer segmentation, you want a whole lot of things over and above what you have in your reporting. For example, you want customer usage patterns, customer information on when they called into your CRM system or into your call center and complained about a product. You may have sales data saying how much did a customer buy, how much did they return, but the reason of the return, what happened before they made the return, all of these things are very important to predictive algorithms. And a data lake could be a great place to save all of that information and feed it into your predictive systems. Let's come to the important point of technology. Most of the time when we think of a data lake, we think of big data, we think of Hadoop, which is not wrong. But just setting up a farm of Hadoop clusters or Hadoop nodes on-prem is not the easiest thing. You need to order these servers, or even if they're commodity hardware, you may still have to order them, get them in place, install the OS, install the runtimes, have somebody full-time to manage all of this. And you know what, when you're thinking of here's the data volume I have, and I'm estimating this would need 75 Hadoop nodes to do it. And you go ahead, order those 75 nodes, get them all set up, which would take a few months of work. And when all of that is set up, you look at the actual data, technology gets better by the time you get that in place, and you're only using 15 of those 75 nodes, which is good news in a way. But the bad news is, what do I do with the other 60 systems that I have in-house now? I could have saved so much money by not ordering them. And this is where a cloud comes in to be very handy. You spin up nodes as you want them, and you spin them down when you do not want them. Two leading cloud providers are the Microsoft Azure stack and Amazon Web Services. And both of these have what we call IaaS, Information as a Service offering for data lakes. Microsoft provides what they call HD Insight, which is a pre-canned system, pre-configured system for building a Hadoop farm. So you don't have to build individual systems, install the software on each of them, and then configure them together. You would spin up these nodes, and it's a very similar concept even with AWS on Amazon, where they have an offering called EMR, Electronic Map Reduce, where you can spin up these nodes in a matter of minutes, if not seconds, and connect them to your existing cluster, and when you don't need them, you just kill them. So you're not paying for them anymore. If you think about it, cloud architecture may not be cheaper than an on-prem solution, but just the flexibility to spin up new nodes and kill them off when you don't need them would provide a good amount of cost savings. But we always think about using the IaaS model. There are some very good things which are being used in the PaaS model, platform as a service. And both Amazon and Microsoft have some very good PaaS models. We call them serverless architecture. So you don't have to worry about a server logging into the OS level of these machines and monitoring disk usage, CPU usage. Do I need more memory on my clusters? All of that is taken care of by the provider. So you can focus on what is important to you, getting the data in and out of these systems. As an example, I have what Microsoft has to offer for their data lake products. So they actually have 3 different products for the data lake. What you see in yellow here is HD Insight that we talked about, where you get a Hadoop node. You can log into the node, you can configure the memory and disk on the node and see what's happening. Versus they have other offerings called the Data Lake Store and Data Lake Analytics. So a Data Lake Store would be a pre-canned, think of it as an HDFS system, Hadoop file storage system, where you don't have to worry about configuring anything or worry about how many nodes do I need, how much more disk do I need to add. You spin up a Data Lake Store cluster and you start using it in a matter of minutes. If it needs more storage, Microsoft will make sure that they add more storage to your account. If you're not using the storage, they will take it off. So you pay by what you actually store in the system, not by what you think you should have. And this is very great, especially in the retail world. For example, we know Black Friday or the time between Black Friday and Christmas is very high. Your volumes could be 3 to 4, maybe even up to 7 times as much as more than a usual day. And that's where having an on-prem solution just doesn't sound as great. Microsoft also has an offering called the Data Lake Analytics, where it's compute on top of your Data Lake Store. And they have some other technologies as well, which I'm going to talk about. Not just Microsoft, but all cloud providers have this, where it just makes it so much more beneficial for what you pay to not have the solution on-prem. Let's talk about the case studies. I have 2 case studies to share with you, and both of them are a little different than the usual data lake, big data kind of case studies that you would hear. So my first case study is for a retailer, one of our clients, which provides a lot of unique and exciting brands to their customers. They are omni-channel. So they do it through their TV networks, they do it through mobile, through online, through their website, e-commerce, and through social channels. So one of the challenges this customer was facing was they have a very mature data warehouse, which by the way is not a challenge, which is a good thing. They also have contracted with third-party vendors for their email campaigns. So if they send out emails to customers, how many customers received the email? How many of them actually opened the email? How many of them clicked on the email and came to a website? And then from that point, how many of them actually made a purchase? So just getting an end-to-end picture of your conversion here. It sounds like a very easy question, right? They have email campaign data, they have clickstream data, and they have their sales data. But all of these 3 data sets are in 3 different places. And something like the clickstream data set was so huge that just getting all the data together was very difficult. Well, it sounds like a very simple question, right? We did an email campaign last week to sell more watches. Did it actually work? How many emails did we send out? And how many of those actually converted to a sale? Well, it doesn't look like that difficult a question, but why is it so challenging? It's challenging because the data is not in your enterprise data warehouse, and it doesn't belong there. Not all data should be in the warehouse. The data is in multiple places, and it is pretty hard to get at. And there are massive amounts of data. And it's just very difficult to combine these different data sets. More often than not, you may or may not have a common key across these different systems. So when we did the data lake for this customer, we did a smaller phase one, and we had specific success criteria for the phase one. We went with the motto of, if we have to fail, we have to fail fast. We do not want to invest 6 months, 3 months, or even 1 month into this and say, oh, that was not the right thing to do. We do not want to buy $200,000 worth of hardware and software and then say, you know what, that wasn't worth it. So we had some success criteria for this client. One of them was everything would be a cloud-based deployment. We would not buy any hardware or software on the premise to do phase one of the data lake. The second point was we will capture data from multiple systems. This would include data from the on-prem data warehouse, email campaigns, and click streams. The data will be stored in multiple different formats, raw files as we receive them, or maybe even database tables for our structured data. The other success criteria was we should be able to combine the data from these different systems in different formats, and we should be able to get good performance. The performance has to match at least of what we get with our on-prem, maybe even has to be better than that. So those were the success criteria we came up with before we started the project. It was a pretty long project. The project took us 2 weeks to execute and about $400 in terms of cost for infrastructure and software in the cloud. So what was the architecture for this? What did it look like? So as I said, they have a very mature on-prem Oracle data warehouse, and they get a lot of files from their vendors, and they did not want to put that in their warehouse. So what they did is they created a staging database in SQL Server, which the marketing team has been using for the last couple years. The problem with that is that it has limited capacity. They were trying to combine that data into a database on-prem, and they could only keep 1 week worth of data with what they were getting in terms of volume from click streams. So what we decided was, let's not even do that. We will take the data and we will put it in 2 very specific Azure products. We will put the data in what is called an Azure SQL Data Warehouse, which is MPP columnar database, optimized for analytics, and we will put the data in the Azure Data Lake Store. So putting the data in the Azure Data Lake Store was pretty easy. It was more of a copy paste. And then we used a cloud ETL solution to get the data from their on-prem data warehouse into the SQL data warehouse in the cloud. And for the vendor data, we copied that into the Azure Data Lake Store, and we used a very innovative technology called Polybase, which lets you run queries, not SQL-like queries, but actual SQL queries. Anything that you can do on SQL, we were able to do on these external vendor files and combine that data on the fly with their sales data that they already had in their on-prem data warehouse. So the solution turned out to be very good. The output of that, we created some dashboards and reports. It was logical for us to be in the Microsoft Cloud and use Microsoft Power BI for this, but it could have very well been your existing on-prem solution. So if you have, say, SAP BI on-prem or any of the other any other solution, you don't have to throw that away. You can still use your cloud data store, be it a data lake or a SQL data warehouse, with your on-prem BI solution. The results actually were very jaw-dropping for the audience. These are, by the way, not real dashboards. These are fake images. I obviously cannot show real client sales data out on a webinar like this. So I just got some data sets from the web. These are not real data sets, but the power that they got in just visualizing the data, combining clickstream data with their sales data was they have not seen that in the past ever. My second case study is for an IoT company that we did a data lake for. IoT is growing, and this company knows that the number of devices they have in the field will grow by 300% in the next 3 years. And they are fortunate enough to have people on the team who have that vision and know that we should grow now, we should gear up for this now. So we are not caught at the tail end of this. They are a data company, and as a data company, they want to provide analytics to their customers around safety, compliance, and maintenance. They need real-time information. If something goes wrong, if you have an IoT solution at home to monitor your home, there's no point in telling you a day later that, oh, you know what, you had a robbery yesterday. If there's something going on, you need to know it, and you need to know it now. So this is where the clients wanted real-time information as well as historic information on what has been happening with their devices. So they want to be ahead of the curve and have their systems ready to adapt to the volume that they're expecting. And not just the volume, but they also want to do newer trends. They wanted to do 3 specific things. They wanted to capture streaming data, they wanted to enrich it, and they wanted to store it so it's available for analytics. So those are the 3 different things that we started off this project as. The requirements were 3. Capture streaming data, enrich the data in stream, not after it is stored or after you have a batch process. If the stream data that I would get is I am device number 1131 sending you the information. Translating that to what is device number 1131? Who does it belong to? Where is it located? Getting the reference and the lookup information in real time and then storing it for analytics. But the point that we also did was, so there's the architecture we did this, and this was all done in the Amazon cloud. Amazon has also some very good products. I don't know if you know more about these products, or feel free to reach out to us. We can talk to you more about quite a few of these, not just Amazon and Microsoft, but also SAP solutions and other things that are available in the cloud and how you can leverage them for a data lake and streaming data as well. So here's what we did. We captured their data using Amazon Kinesis agent, which then passed it to an Amazon technology called the Firehose, which then put the data through a Lambda process into a data lake. And then it also did some live processing and storage of the data in a high performance analytical data warehouse in the cloud. So all of their customers were using the standard canned reports from here. And what happens to the data lake? This is where their data analysts, their data scientists, and their marketing team was going in to get more insight. These are the kind of folks who want more data that is available than in the data warehouse. With that, I want to make some closing statements. So what we have learned today, a data lake will let you do vast storage. It supports all kind of data sets, structured, semi-structured, and unstructured in its absolute raw format. A data lake does not replace your data warehouse. It augments, it adds on to your data warehouse. And a data lake can provide you newer insight for predictive and to your data scientists faster than them having to worry about where do I get this data. I am almost on the top of the hour. Call to action, if you need more information on anything that you've seen today or need to discuss, should you have a data lake, what are your options, how should you do it, please reach out to us. We will be glad to talk to you about it and define next steps on what should you do so you're ahead of the curve with the data lake and the changing data world. I was hoping I would have some slides for Q&A. Unfortunately, we are at the top of the hour. If you do have any questions, please submit them to us. You can do it via email or even via the text box that you have on your webinar window here. And my apologies, we'll not be able to get to the questions today, but we will reach out to you and get you answers to your question. With that, let me hand it over back to Megan. Megan, we cannot hear you. You're possibly on mute.
Thank you. I was. Okay, thank you, Manish. That was a great presentation, and thank you everyone who joined us today. We hope to see you at future webinars. We do have more Data Lake webinars coming up in the future as well. For the questions that were submitted, we do promise to follow up with you for those, and we hope that you'll enjoy the rest of your day. Thanks for coming.